Hi everyone. Today we are going to discuss about the illumination. That is the chapter of the utilization of the electrical energy. So the main concept of the before going to the illumination, we have to know the what is meant by light. Okay. So here the illumination concept is before going to what is meant by light. So here, light is simply very small part of the electromagnetic spectrum. Okay, so that is the visible portion of the electromagnetic spectrum. So that is the visible portion of the electromagnetic spectrum, and it extends from about 380 to 780 nanometers. Okay, so that means which distinguishes as the part of the electromagnetic spectrum, ultraviolet rays and violet, violet, blue, green, yellow, red, yellow. Okay, so these are the visible colors. Okay, so that is our distinguishing of the 380 to 780 nanometers. So that is our visual system. Okay, so that is the when the radiation of that spectrum on that region is absorbed by the photoreceptors of the human visual system. Okay, so that is our the light. So it cannot be separately described in terms of radiant energy of visual sensation, but is the combination of the two. Okay, so the visible spectrum is having ultraviolet radiations and infrared radiation. Color is very important for the visible spectrum. For UV radiations, that is having a shorter wavelength, and for infrared radiations, the wavelength of the uh, visible light is long. Okay, so those are the main three types of the radiations, the main basic concept of the radiation. So before going to the light, so coming to the light, it is defined as the main simply the definition of the light is it is defined as the radiant energy from a hot body that produces a visual sensation upon the human eye. It is expressed in lumen hour, and it is analogous to watt hours, which denoted by the symbol Q. Okay, so here before going to the luminous flux, so first of all we know the what is meant by a reflection. Okay, so reflection means what? So the main basic concept of the optics. Okay, so light encounters on the surface already, Okay, so that reflects away from the surface or refracted through a surface. So when the light falls on the surface, polished surface or rough surface or matte surface or diffused, so based upon the surface, the light is diffused. That means reflected back from the surface. Okay, so that reflection, first of all, and refraction means what? When the light travels from the one material to another. Okay, so that means it bends or that changes the velocity. So two factors, it depends upon the two factors, that is the incident angle theta and the refractive index material. Okay, so now we are going to see the diagram. How this is our simple lamp, like fluorescent lamp or incandescent lamp. Okay. So we are giving the power to this lamp. After giving the power to this lamp, when switch on the lamp, what happened? The light will glow up, right? So here in this case, the from the light energy, that means radiant flux is produced. Okay, so that radiant flux is in terms of it is having the flux lines is we call luminous flux. Uh, Power lost as a non-luminous flux, and power lost by conduction or through convection. So here some power is lost. So what is meant by luminous flux? It is defined as the energy in the form of light waves radiated per second from. Okay. So a luminous body, it is represented by the symbol psi and measured in lumens. Okay, na? So these are the main basic terminologies in the illumination. So now we are going to define the radiate efficiency. When electric current is passed through a conductor, some heat is produced. Okay, so that heat is in the form of the what I square or losses, which increases the temperature of the conductor at a low temperature. Okay, so this conductor radiates the energy in the form of heat waves, but very high temperatures, and also radiated energy in will be in the form of the light as well as the heat waves. Okay, na? So here the radiant efficiency is defined as the ratio of the energy radiated in the form of light and produces sensation of the vision to the total energy radiated out by the luminous body. So here what is meant by radiant efficiency? That is the energy radiated in the form of the light by total to the total energy radiated by the body. So the main terminology in the illumination is plane angle and solid angle. We have to know the what is meant by plane angle. So if you see the diagram, plane angle, okay. So the plane angle is the what? A plane angle is the angle subtended at a point. Okay. So the angle is subtended at a point in a plane by a two converging lines. So it is denoted by theta. Plane angle is denoted by theta, and the Greek letter, it is the name is Greek letter and usually measured in degrees or radians. Sorry. One radian is defined as the angle subtended by an arc, a circle whose length by an arc of a circle whose length is equal to the radius of the circle. So if you see the diagram, plane angle, so this is our theta. So this is our light or source. From the source, the light is radiated. So it is having a radius and having an angle is theta, which makes an angle from the illumination. That is the luminous flux lines. These are the luminous flux lines from the source, and from the source, the up to this level, the radius I am considering is r, and I am drawing some curve, so it forms an arc, so which makes an angle is theta. So this is called a plane angle theta. You can calculate it by using the formula arc per radius. So how you can calculate plane angle is, so that is arc per radius, you will get the plane angle. So the units for the plane angle is radians. Okay. So now we are going to discuss about the solid angle. So what is meant by solid angle? Solid angle is the subtended at a point in a space by an area, that is the angle enclosed in the volume formed a numerous lines laying on the surface and meeting at the point. So it is denoted by omega and it is measured in steradians. Okay. So that is the surface area we are considering. Small difference for the plane angle and solid angle. So here we are considering a surface area. Okay, solid angle is represented with omega. So the area under the radius square. Okay, so that is the solid angle and it is given by the units is steradians. Okay, na? So omega is equal to area by sphere, area of the sphere by radius square, and 4 pi r square by r square, and you will get the 4 pi steradians. So what is the solid angle? 4 pi steradians.